Good morning, good afternoon, good evening, depending on where you have joined from today. Welcome to 6 query tuning techniques that will solve 75% of your performance problem. I mean, not your performance problem, your SQL Server's performance problem. My name is Amit Bansal. I'm going to be your speaker and host for the next 75 to 90 minutes. And there are 6 precise demos, very crisp from real world. We have learned a lot from production servers of our customers, and I've created a few academic examples that I'm going to present to you. So the motivation behind this session and the content really is that when I learn about performance tuning from customers' problems, working with their large data, understanding their query tuning issues, performance issues, interacting with developers and DBAs, whatever I learn, I try to put that into academic examples. And I saw that there are common patterns and anti-patterns with customers. And those common problems is what I've taken and I've converted them into this session and the demos that you're going to see. So it's a simple motivation. The inspiration is that many of your SQL Server deployments potentially have similar problems. Now, what are your takeaways? You are definitely going to learn 6 different problems. You will know about them. You will learn how to fix them. And not only 6, during this course of 75 minutes to 90 minutes of interaction, you're going to learn a lot more internals about SQL Server and performance tuning. Some of the problems that I'm going to talk about, probably you already know about them. You have faced them with your customers. You have even solved them. I totally appreciate that. Try to give some feedback on the chat window or in the Q&A window about how you, when you faced, how you solved it. It could be some learning for the audience, and I'm going to call that out. But I hope there will be a lot of new stuff, new content that you can learn in this session. All these scripts and the content is going to be made available to you after this event is over. So we have 2 more deliveries on Saturday. So we're going to package all of that on Sunday and give it to you. There is a common question that we get about recording. We're not sure if we will be able to record the session because the entire team, as you have seen just before joining, is glued and is working quite hard behind Data Platform Virtual Summit. So not sure if we will be able to get that much time, but in some ways or the other, we'll try to bring out more content to you. So let's see how it goes. The other thing is about housekeeping, which is Q&A. So please have your questions coming in. Use the Q&A panel of Zoom. Some of you are watching live on YouTube. So I'm just trying to see, there are many of you on YouTube out there. So if there is room, you can hop over into Zoom. But if you're not getting inside Zoom due to limit capacity, continue watching on YouTube and use the YouTube chat window or the chat box. And if you're on SQL Mason's live page, use the chat box out there. Our moderators are constantly watching. So if you have questions, put them in those chat box. I promise no question will get unanswered today. So irrespective of where you're watching it, use the tool to put down your questions. We'll bring them on Zoom and answer the questions live. So friends, let's get started with query tuning, 6 query tuning techniques. And I'm on Twitter, _Bansal. That's my Twitter handle. I've been working with SQL Server for many years now. And the idea is quite simple. As an MVP, as someone who's a community freak, so to say, whatever I learn, I just tend to share it with all of you. So hope you enjoy this content. Let's get started. The first one, very elementary, sargability. Sargability is a made-up term. It's not an official English word. It means search argument ability, the ability of the SQL Server engine, and more precisely, the optimizer to go into the index and have the seeking capability in the index. So that is what is meant by sargability. So sometimes what happens is, even if you have the right index on the table and the optimizer is using that index, there are particularly 2 ways on how you can search on the data in the index. Either you can seek or you can scan. And the problem here is that the optimizer is using the index, but instead of seeking, it is scanning. So maybe the query is not written in the right way, which limits the searching capability of the optimizer, and you land up scanning instead of seeking. And now what does this mean? If you think about the index, the B tree structure, and I think many of you know this, So you have the root page, you have the intermediate levels and the leaf level. So scanning would mean go to the leaf level directly and scan all the leaf level pages. And that may turn out to be quite expensive if this is a huge index. Really, when you create an index, you want seeking capability. So you can traverse using the B tree structure from root to intermediate to the leaf level. Now, sargability is a very common issue that I see with customers, and sometimes they're kind of unaware as to why this is happening, but it's really everything boils down to the way the T-SQL code is written. So let's dive deep into the demonstration and we'll discuss more concepts as we go along. So in the first demo, let's use AdventureWorks 2016. Many folks think that AdventureWorks is not a good database. It's not about good or bad database. It's about good or bad data model. Even if I was using the world's best database or the world's largest database, the learning would have been same. So no worries if you're using AdventureWorks. In AdventureWorks 2016, first, let's create a index on modified date column, which is in sales order detail. Let's call this index as IDX SOD modified date. And you know why am I creating this index? Because I'm going to search on this table. I'm going to fire a select query and I'm going to filter on modified date. So we have the database, the index is created. Let's turn on statistics time and IO. Now these two statements, very, very popular. All of you know about this. Time will give me time information about my query, how much time it has taken for the total execution, the elapsed time, how much time has my query spent on CPU, that kind of information I'll get from time, and IO will give me IO information, the physical reads, the logical reads, the read ahead reads, etc. I use these two quite frequently when I'm doing query tuning stuff. Now let's get down to the query itself. The query is right in front of you. This is a very simple query where you're fetching a few columns from sales order header and you are joining another table called sales order detail. And then look at this, you are filtering on a column modified date. This is the same column on which you have created the index. Now, when you look at this query, I'm sure some of you are trying to figure out where is the problem. And many of you know the problem is right in the where clause. Look at this where clause. The problem here is that on the left-hand side of the equality operator, the column modified date, you're doing some mathematics on that, right? And on the right-hand side, you have the expression. Now, the problem with sargability here is the capability to seek on the index gets lost. The optimizer loses that because when you have an attribute on the left-hand side of the column and you're applying these T-SQL functions like convert or date time functions or string functions, it is no more an attribute. It becomes an expression. And then the overall T-SQL query is expression A compared with expression B. And at that point of time, because it is an expression, you will not be able to seek on the index column modified date. So this means that if you execute this query, let me select it. Let's turn on actual execution plan and click on execute. What you're going to see is the query runs, you do not get any data. It's not compulsory to get data, right? You can always get empty results set. But the problem is, let's go to the execution plan and you can see the first thing in the execution plan which will catch your attention is that instead of seeking, the optimizer is scanning. Let's take the cursor over the operator index scan and you can see this is the same object that we have created. So this was IDX modified date. This is what we call as the optimizer's access methods. How are you accessing the data? Are you seeking? Are you scanning? So on and so forth. So a scan is happening here. And if you go to the messages tab there, you can see in perspective in terms of IO, you can see sales order detail has 337 logical reads, right? Not a big number, but again, remember, this is just a demo. If you take the same concept in real world, you will definitely see big flying numbers. If you go and look into the execution time, the overall elapsed time has been just slightly over half a second, 600 milliseconds, and query spent about 78 milliseconds on the CPU. So you know that this is a typical sargability issue, right? The query is non-sargable, so to say, and you got to fix it. So how can you fix this? Well, if you go and rewrite the query with something like this. Now, if you see when we say where modified date is greater than equal to something and less than and the same column, of course, is less than equal to another expression. What you have to make sure that when you are rewriting the T-SQL query and you are trying to fix the sargability issue, both the queries, the previous version and the modified, the revised version, should be logically equivalent. And in this case, they are logically equivalent. Let's go and execute this and see what happens. So first, well, let's go to the messages tab. And what you will see here is logical reads from 337 have come down to 3. And I think I can guess that right, because now seek is happening. So simple, right? 3 reads. So you have the root page, 1 page in the intermediate level, and another page at the leaf level, maybe. So 3 reads. And if you look at the total elapsed time, remember the total elapsed time was something like 600 milliseconds, and now it has cut down by 3 times. So now you have like 200 milliseconds and very negligible time on the CPU, because a lot of IO has been cut down. Remember, IO is the CPU function. If you do a lot of IO, you will have CPU spiking up. So in this particular example, we fixed it and there's hardly any CPU usage. Let's go to the execution plan and verify. So if you look at the index now, we are seeking, and that is index seek happening, and you are seeking on the object IDX SOD modified date. Now, this is a very, very basic example of sargability. So again, to summarize, the problem is that you have the index, but you're not seeking on that index. Instead, the optimizer lands up scanning. You got to go and see whether the query does make sense. And if there is something that you can do with the query, rewrite it to ensure that you are seeking. Now, of course, SQL Server helps you here. There are a lot of DMVs like index usage stats, etc., in combination with a couple of other helper DMVs that you can use to find out what's happening with your index. Usage stats. Are you seeking? Are you scanning? That kind of information SQL Server can give you. Now, of course, the session time that we have does not allow me to go into the depth of so many different aspects and artifacts of SQL Server, but just calling this out, that those are the helper DMVs that you can use to find out, okay, I have all these indexes. How are they being used? Is SQL Server seeking, or is SQL Server scanning on them? So those numbers and statistics you can get. Now, sargability is just not this, friends. I mean, it's a wide concept, and a lot has been spoken about. There are a lot of resources available on the internet. Now, simple things, you know, let's say you have an index on, let's say, last name, and then you say, select star from this table where last name is equal to Bansal. And when you do that, you may expect the optimizer to seek on the index because you put the literal as Bansal. But suppose you put a wildcard character in your literal. So you say, percentage Bansal. So like percentage Bansal. If you do that, then SQL Server has no way to start searching the data because you have put a wildcard character, and again SQL Server will start scanning instead of seeking. And these are little things that developers, DBAs, they all miss out. But that's the whole idea of keeping these common problems in mind. Bansal percentage wouldn't be a problem because percentage, the wildcard character is coming at the end of the string. So when you have this index key column and the attribute values that are being searched upon, make sure that there are no wildcards preceding the literal. So there could be many such examples of sargability. So this is the first common problem that I see generally across many SQL Server deployments, and it's a common thing. So you know that indexes are quite powerful. In many cases, most cases, indexes help you improve the performance of your query. Now remember, index is not a magic bullet. It just by the mere creation of indexes, you don't improve performance of the queries. Remember, indexes are searching mechanisms. They help you get to the data faster, not just automatically improve performance. And this particular case could be even worse, that you have the index, you created a huge index, you are spending resources on maintaining that index. Indexes could be hundreds of GBs in size, depending on how large the table data was and how big the size and the number of rows that you have. And you are not seeking. So look at the resource consumption there. Well, this was the first demo. Let's close this. Hope this was useful. Let's move on to the second demo. Now, the second demo, I just didn't know how to name the second demo, the second problem that I see. So I kind of just call it what I hear from customer. Hey, Amit, Seek is not happening. Now, in the previous example, I showed you an example of non-sargability, where again seek was not happening. So don't confuse with the first one and this second demo. In the second demo, I am actually not showing you sargability yet. I am showing you another example, another common pattern, another reason why you have the right index in place, but SQL Server is not seeking on it, and you're not able to figure out what's going wrong. Again, let's use AdventureWorks 2016 and turn on actual execution plan. Look at this very simple query. Select star from person.person where first name is equal to Ken. I try to keep queries very simple in sessions like these so that you don't spend time deciphering what the query construct is, etc. The concept and the learnings are more important. When I select this query and execute, you get some data, which is good. If you go to the execution plan, you can see in the execution plan that again, the index is being scanned upon. Now, let's say you know that there is an index which uses first name, but you are wondering why is the optimizer not seeking? Let's try to figure this out. Okay, I am seeing that index is being used, but it is being scanned upon. Let's go ahead and take the cursor over the iterator and let's zoom in and scroll down and look at the object name. When I look at the object name, it says IX person, last name, first name, middle name. Now, great. The naming convention was well followed. Now, if you look at, you will see that the index is created on 3 columns, last name, first name, and middle name. And probably the order of columns is exactly what's mentioned in the object. You can go and verify in Object Explorer or with DMVs what the index definition is. But let's trust AdventureWorks right now for the moment. So you have this index, last name, first name, middle name. You know, friends, what? Creating a single column index and troubleshooting single column indexes are relatively easier. Sometimes with multi-column indexes, things get a little trickier. And today, I will talk about a few things related to the multi-column index. Now you have this index and let's say you are the developer DBA, you are the SQL Server practitioner who's writing all these queries and you are trying to figure out why seek is not happening. Now, okay, there you go. So why is seek not happening? So there is, in the index definition, first name is already included. And the question is seek is not happening. So here is the deal. Your query is only trying to search on first name. Your query construct does not include last name and middle name. And how the rule of the optimizer works is when you create a multi-column index with column 1, column 2, and column 3, seeking happens from left to right. So if you are not seeking on column 1, you cannot seek on column 2. If you are not seeking on column 1 and 2, you cannot seek on column 3. This is the rule of the multi-column index with the optimizer. Always keep that in mind. When I started talking about this to some customers that, you know, you have this query and you have put first name into the query, but actually the index is on last name, then first name, then middle name. So last name is not there. So, and the customer thinks, okay, so shall we include last name? Well, there are different ways to look at the problem and there are different solutions. You may create an index on first name. That could be possibility 1. You may modify the query if the report permits. You may, if the data set is small, the client application can discard last name and just take first name if that is the need. But the whole idea is order of columns in your select query does not matter. This is a misconception that many SQL folks have, that if I change the column order in my select query, I will somehow land up using seeking on the index and I can match that up. Not really. Irrespective of the order of columns in your select query, first name, middle name, last name, middle name, first name, really doesn't matter. What only matters is that does your query have those columns or not? But friends, the order of column in the index does matter. That is very, very critical. So when you are designing indexes, when you're thinking about indexing strategies, please keep this in mind, because you may land up creating more indexes. Like you may land up creating an index on first name, another index on middle name, another index on first name, middle name, and last name, and all these types of permutations and combinations. That is only going to just get from bad to worse, because you will land up creating too many redundant indexes. Try to create indexes that will just not satisfy one query, but probably multiple set of queries. And there will be places where you may have to compromise a bit. Now, in this particular case, as I said, that there is no just one solution. It really depends on the workload, on the querying pattern. What are the other indexes available, and what are the other queries that are running around this person table, and how's the filtering happening? But the learning here is that seeking is not happening because of the order of columns, and the rule is I am not seeking on last name, so I cannot seek on first name, and SQL has to go to the leaf level, scan the entire data, search for every value where the first name is Ken. That is the problem. So let's go and fix this. Now, fix means trying to show you how this works is now if you see I've included last name and first name. And if I select this and execute now and go to the execution plan, you can see that now I am seeking. It's the same object, but instead of scanning, I am seeking. So the idea here now, of course, you might think that, well, my query is not logically the same because now I have another filter. You're absolutely right. The query is not same. As that's why I said that I may not have the solution on how you may want to rewrite the query or how you may want to redesign your indexes. Is last name really being used to search? If not, why not just modify the index? I mean, drop and recreate it and put first name as the first column and last name as the second column or third column or whatever. Probably that can do the job, isn't it? And if that's the case, it will work because see, and I will show this to you. Let me just change this one and take it here to show and prove the point that if the search was only this much, where last name is equal to Sanchez, and I select this. Now remember, I'm seeking on last name. Last name is the first column. When it was first name, it wasn't seeking, it was scanning. What about now? So if you execute this and go to the execution plan, yes, you are seeking, and this is what you wanted. So this proves the point that yes, indexes follow the left-based searching mechanism, left-based subset. So you start from leftmost column and go all the way to the rightmost column. And great, I remember that I can show you the wildcard character thing here. So this is there. So what if I put a percentage here? This is what I was trying to talk and explain in the first demo. So this makes the query non-sargable now. Remember, this was seeking. Now because I put the wildcard character and instead of equals to, let's put like there and execute this. And you will see in execution plan, yeah. And now you are, sorry, let me zoom this out again because the tooltip is coming up. And now you can see again that you are scanning. Why? Because there is wildcard and the seeking capability is lost. This is again a non-sargable query. Okay, and you know, when I was doing this, I got this feedback from some attendees. Okay, will like really have seek? I mean, will like work with seek? And when you use like, will optimizer seek? Yes, it will. It's not seeking right now because of the wildcard character there, which makes it non-sargable. So what if I just remove the percentage from here and put here at the end? Now, searching from left, you have the character, it will seek. Let's go and execute, and you can execute, and you can see that we are seeking. All great. And what if there is no wildcard character at all, just like Sanchez or anything, right? Will it seek? There's no equality operator. Let's go to the execution plan. Yes, you are seeking. Great. Now, if you know the second, so just to summarize, the second demo was not the same as first demo. I just took the second demo in the liberty to kind of expand more on sargability, which I explained in the first demo, but the first and the second demo were distinctively different. But the problem was common, which is you have the right index in place, but seek is not happening. It's scanning. And how can you fix that? So I just took up these two common examples that I see. All right, friends, let's go on to the next demo. Hope you're enjoying. So can I get some responses in the chat window? Are you glued to the demos? Are you enjoying it? And if you're, we have some room, maybe, no, not much, I guess. So maybe people on YouTube are continuing to watch there. So if you have questions, please keep posting them in YouTube chat window. I have my friend and colleague Satya who's taking down all the questions from YouTube, from Facebook, from Zoom, and we will answer them at the end of the session. And I will tell you, friends, after the session is over, stick around for the Q&A because you learn a lot from questions from your peers, because different people work in different backgrounds, different deployments, different challenges, and you learn a lot from the questions. I learn a lot from your questions. So stick around for the Q&A. Okay, time to move on to the third demo. I'm just looking at the time. Okay, we're doing well. Let's move on to the next one. Implicit conversion. Another common problem that is there around in SQL deployments. And I will assume at this point in time, many of you really know about implicit conversion. But this demo is just not going to be a very simple demo. I'm just going to show you a query where implicit conversion is happening, and then I will modify the query. Then implicit conversion will not happen. No, I'm going to take you to two different levels here. In the first example, I will just show you a basic implicit conversion so that all of us are at the same page. Then I will step up a bit and show you something else with implicit conversion. Then I will show you the third part in the same demo on how you can fix implicit conversion in better ways, or how you can do things in better ways. So let's get started. We are using AdventureWorks 2016 again, and here is a very simple query where you're doing a varchar to nvarchar conversion. Query is quite simple. You're joining two tables, fetching some columns. The problem is here, where account number is equal to some literal, the constant that you have specified here. Now you have prefixed this literal with n, which means you're telling SQL Server that this is Unicode data. So this is nvarchar on the right hand side of the equality operator, and account number. What's the data type of account number? So if you take the cursor over account number, and I will show you that with the tooltip, you get that this is varchar. So what is SQL Server going to do when you send this query to SQL? It's going to figure out what's the best way to do this conversion and possible data types conversion. So SQL Server is going to spend some time. That some time could be very negligible, but it's still going to be something. And SQL Server has to figure out the conversions from which data type to which data type. And that's going to happen. So let's turn on actual execution plan, and let's also turn on set statistics time to see how much time is SQL Server going to spend in doing that conversion. And now let's go and execute. When we execute, we get the data. Great. Let's go to the execution plan. Now you have a simple execution plan in front of you, and I'm sure you are looking at the select operator there. So if you see the select operator there, there is a warning symbol there, exclamation mark, which means SQL Server is trying to tell you something. If you take the cursor over select operator and zoom in on the tooltip, you can see the warning there. The warning clearly says that type conversion expression convert underscore implicit something 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 may affect seek plan and query plan choice. Great. I'm quite happy that SQL Server is giving you all these warnings in Management Studio in the execution plans, and you can go and take a look at them. Now, I already told you implicit conversion will happen, and yes, it is happening. And SQL Server is telling you that because of this implicit conversion plan, seek plan may be affected when the optimizer is computing multiple permutations for the query plan. If you go to the messages tab here and look at the time factor, you can see the total elapsed time was just about half a second, 481 milliseconds. But the most interesting thing to note here is that the optimizer has spent about 235 milliseconds on CPU, the execution, 235 milliseconds. Okay, so just keep this in mind. Now let's do something. Let's go and fix this. And remember, friends, this is a very, very elementary demo, very basic, and I'm sure all of you know this. So I'm going to just fix this, and I'm going to remove n. So see what I've done. I'm just removing n, and I'm just ensuring that on right-hand side of the equality operator, I have varchar. Now it is varchar to varchar. There will be no conversion. Let's go and execute this, and you're going to see that in execution plan, no more warning symbol, neat plan, absolutely no issues. Let's go to the messages tab and see how much time has the execution engine spent on doing all this stuff. So the elapsed time gets cut by half, right? So now you get 254 milliseconds, and there is hardly negligible time the query is spending on CPU, which is 0 milliseconds. So you can see that with with not having implicit conversion happening, you are saving CPU time. Now comes the interesting question. When I was talking about this and showing this to customers, people do come back with questions like, does it really matter? Does it really matter saving this much time in SQL Server? I mean, does every millisecond matters? My answer to that is, when you look at the query in singleton, when you look at just a single execution of the query and you are seeing this improvement of just a few milliseconds, it might not be very motivating. It might not be very encouraging. But look at the larger picture. All of you are working with SQL servers that are deployed, and there are hundreds of users connected to them. and there are all these users firing all sorts of ad hoc queries, OLTP queries, very short-lived queries like these. This is a very classic OLTP query, and you're firing all the time to SQL Server. If you look at all of that in totality, and if you fix a little thing like this, think about the magnitude of time that can be saved, the CPU time. So to just kind of simulate that, why not put this implicit conversion back? I'm putting this in, and let's go and fire this query, let's say 40 times. So I'm saying go 40, which means I'm telling this entire batch to just go and hit SQL Server, come back and do that 40 times, 40 round trips, 40 executions, and let's record the total time. So while this is running, I'm going to not turn on actual execution plan. I'm going to turn it off, because for every execution, I'm going to get the plan. That's not required now. We are only going to see the 40 executions, how much time this takes. So let's go and execute. Now, 40 executions are happening one after the other. They're going and hitting the engine back again. The good thing is right now, at this point, the client and the server are on the same box in the same VMV. So things are going to be faster. But in real world, clients are way across, anywhere across the globe, hitting the server over the wire and whatnot. Now, if you look at the total execution here, you can see that this has taken about 17 seconds. So those 40 iterations took 17 seconds to execute. Now let's do something. Let's just remove the n prefix there and make sure that there's no implicit conversion happening, and execute the same thing. And again, this is just simulating, right? And I'm running it an iteration. And if you just multiply this by 100 users, look at the magnitude. Now, when you run this, how much time this takes? Earlier, it took 17 seconds. Now the total execution has taken just 7 seconds. So if 200 milliseconds was not convincing enough, you will see 10 seconds. Hopefully that is convincing. Multiply that 10 seconds with 100 users, right? Those are like 1,000 seconds, and a lot of minutes and hours and so on and so forth. So yes, every millisecond second does matter. Look at the overall trade-off in the larger picture. So the very basic demo is done. I am assuming that many of you had already known about this. But now let's move on to the next level of this demo. And so the first one was just showing you the implicit conversion. Second one was the bigger magnitude of it. Third one could be answering some of your questions that, hey, Amit, if I really have conversions to be done, I mean, then what? I mean, because there could be a real need to do the conversion. Yes. Why not do explicit conversion, right? Explicit conversion. Tell SQL Server, what do you really want to do? So I'm telling SQL Server that, okay, my account number is varchar, and I want to convert this string to varchar, and I'm using the convert function. That may just do the trick. I'm not letting SQL Server spend time in deciding all the different permutations and combinations of the data types. I'm just telling SQL Server, go ahead and do this. What will be the scene here? Well, let's look at this. So why not simply straight away jump into running this 40 times, and that will give you the answer, isn't it? We are going to do this 40 times. I'm going to turn off actual execution plan. Idea is that this should complete in about 7 to 8 seconds, isn't it? And if it does, we are the winners. So let's go and execute this 40 times. Explicit conversion. Now you're telling SQL Server from where to convert to what data type, etc. And hopefully this should complete in 7 to 8 seconds. Yay, you are the winner. Just like Data Platform Virtual Summit pass holder, you're the winner with 7 seconds of execution. That's there. So you've seen the 3 level of demos there, right? Okay, so friends, first demo done, second demo done, and third demo done. 6 query tuning techniques. We are halfway through. And because I mentioned about DPS, I'm a little excited to talk about DPS. This conference is just a month away, and but I will take your permission. So in the chat window, if you allow me, I want to digress 2 minutes, like a small break, have some water and talk about DPS, and then do session 4, 5, and 6. Just give me some feedback. How is it going in the chat window? Are you enjoying the demos? Worth your time coming over today? Great. Thank you for the great feedback, friends. All right. So we we were talking about all these demos, and yeah, DPS just came in between. So I'll just take 2 minutes. You have been probably hearing a lot about DPS. You just watched a few slides and a few videos that I recorded to kind of encourage the community. The whole idea is very simple. Apart from all the SQL stuff that we do as a team, once in a year, we do this data platform summit, very large scale event. We get the world's best trainers, speakers on Microsoft Azure data, SQL Server, Power BI, Azure data stack, analytics, artificial intelligence. And for the last 5 years, this conference was happening in Bangalore. And for all obvious reasons, for this pandemic, COVID, when everyone goes virtual, we took the conference virtual. And we had only one thought: how can we make this conference more inclusive, and how can we get different diverse cultures and nations? And guess what? We decided to run the conference non-stop, round the clock, which means the conference is actually running for 72 hours round the clock, 3 days and 3 nights, which means wherever you are in whichever part of the world, you can join the conference. We wanted to enable this for the community in collaboration with Microsoft. We're very thankful that Microsoft supported us. Not only Microsoft, sincere thanks to all MVPs, my MVP colleagues, friends from all over the world came and heavily supported this. And guess what? 170 speakers today, maybe 180 as I speak to you, 180 speakers came on board with some fresh, unique, highly curated content. Out of 180 speakers, 60 folks are from Microsoft, from the product groups, your favorite SQL Server, BI, Azure Data Stack, AI, and they're coming up with so many sessions. And MVPs are coming up with some real world experience, some great content. In total, we are delivering 200 sessions across 5 parallel tracks in those 72 hours. And the best thing, our delegates are going to get the recordings for all of them. It's quite an effort on our side to execute this conference, get all the recordings done there, edit, post-event processing, etc., and kind of put them up on whatever streaming platform and give you on-demand access to the content. Community is loving it. As I speak to you today, there are registrations from 32 countries, which is very motivating, very encouraging. Not only this, we thought, let's go one step beyond, which no conference is doing. Our training classes, pre-cons and post-cons, are being recorded. And I want to take this opportunity and thank our speakers, all our training class speakers who agreed, of course, that the recordings could be shared with the delegates. So if you take up any training class, depending on which time zone you are in. Remember, the training classes, pre-cons and post-cons, are also running around the clock. So you can choose 8-hour classes divided into 4 hours each day. So you can balance your learning with your work and personal life. And that's another great thing about the virtual world, that you can really customize this stuff. So if you sign up for any training class, you will get the recordings of that class. That's quite a big deal. That is, I will say, true value for every community member across the globe. And of course, the third thing is, even when I sign up for a conference, I definitely look at the price factor that, I'm going to spend my money. I'm going to spend my employer's money. Is it worth my time? Is it really worth it? And if you look at the pricing today, probably in less than $300, you can get a training class, and you can go into the summit, and you get the recorded content for all of it for next 12 months. Watch as many times as you want. So total true value, and I will encourage that you, your colleagues, your friends should come over Data Platform Virtual Summit, join. You can sign up for multiple training classes, because even if you're not able to attend a specific training class, you still get the recordings of it. So I'm quite proud of our team, Microsoft, all the MVPs who have come forward and supported this global initiative to take this to so many countries. And let me call this out. If you are from a low income group country, we have special packages that we have designed to make it inclusive. So any country from the European nation, Middle East, Africa, or APAC region, if you are from India and your employer is not sponsoring you, I know how Indian companies work, so no offense, but that's the reality. There is pandemic, and there has been a step back due to COVID and cost cutting, etc. Just drop an email to contact@dps10.com. I'm going to ask my colleague Satya to put that email down, contact@dps10.com. Just let us know that your company is not sponsoring you, but you still want to come on board DPS, you want to sign up for a training class, or the conference, we'll figure it out. We'll do something because it is a community conference. We don't want anyone to be left out. The whole intention of launching this in this virtual world and make it more inclusive, running round the clock, days and night, was to make sure that everyone can join. The whole world is invited. We want to work with that motto. And friends, for all of you specifically, don't kind of distribute this out because you joined today's SQL Maestros live training. There is a special 55% discount code, SQL Maestros. We have limited seats, probably till Monday or Tuesday or Wednesday. This is going to be there, this discount code. So if you really feel encouraged, if you see value, just go and sign up and use this discount code SQL Maestros, which will give you slightly more, 5% more than what is available online. So the discount code is SQL Maestros. And friends, take a look at our training classes, real gem. I don't want to take just one name, because all of them are masters, right? And probably just before joining, you must have seen that video, and you can go online to dataplatformvirtualsummit.com and explore the content yourself. Please explore the content. Content is king. That's my background, which I'm donning today. So yes, focus on the content, grab it. That's the whole idea. Okay, with this, let's move on to the next demo, which is dynamic plan cache. And this is also a common thing that we see with customers. This is a long demo, friends. I mean, this is a demo which is like 1 hour because I'm trying to show you a lot of things here. And I was in dual minds if I should include this example in today's class because of its lengthy nature. But I thought, okay, I can cut this down and show you only the crux, the key thing that you should keep in mind, and probably it will be useful. So, you know, what happens is dynamic SQL is great and dynamic SQL is good, but I see that dynamic SQL has two sides of it. There's the good world of the dynamic SQL and the bad world. And in the bad world, there is this concept of parameterization that you need to really understand well. So if I look, scroll down, just let's jump into the query. And first, let me show you the query. Here is a query, okay? What are we trying to do? In AdventureWorks here, we are trying to run this query, which is going to fetch data from human resources.employee table, where manager ID is equal to something. Now look at this query. You take this query and you put it into a local variable here, SQL string, and then you're trying to execute the SQL statement dynamically using sp_execute SQL. Simple dynamic SQL concept. But how are you concatenating the manager ID? Where is the manager ID coming from? Manager ID comes from another local variable @CNT, and you run this entire query, this batch in iteration for 100 managers. Let's assume there are 100 managers. And then you run this query for each manager. Where is the problem? The problem is here in this query because you have not done explicit parameterization. The problem is when this query runs, when this batch runs with 100 iterations and you are incrementing @CNT every time, SQL Server is going to create 100 plans, one plan for each execution of the query. Why one plan for each execution of the query? Because there is going to be a different manager ID in each execution. So one plan for manager ID, second plan for manager ID 2, third plan for manager ID 3. That's going to be bad. This is a scenario which we also call as plan cache bloating, because you have this ad hoc query that is being executed with this dynamic SQL facility, and in the plan cache you will have 100 plans. In other world, in a better world, you could have explicitly parameterized this query so that there could be only one parameterized plan, and irrespective of any number of manager IDs, for example, but there could be just one parameterized plan, and that would be great. So first, let's look at the bad thing, and then we'll look at the good thing. So let's go and take this query here, the helper queries, for us to troubleshoot a few things. I'm going to copy this one and take it in a new window and put it here. What am I trying to do? I'm trying to see how many plans are there in the plan cache, and then I'm going to look at the plan cache size in kilobytes. Let's go and execute this, and you will see that right now there are about 1,000 plans in the plan cache and about 204,000 kilobytes. Okay, just to make our calculations simple, why not do dbcc free proc cache? dbcc free proc cache and dbcc drop clean buffers. Just because I'm showing them in the demo doesn't mean you start running them in your production servers. Okay, so don't do that, please. This is just for the demo. I did DBCC free proc cache, which means I cleared off the planned cache. And now you can see that there are only 2 plans in the planned cache, and the planned cache size is 192 kilobytes. Keep this number in mind. Let's go and run the query, the bad version here where there is no explicit parameterization. Run it in a loop and see after the total 100 executions of this, how many plans do we have in the plan cache? And while it is running, why not just go back to the other window and run the helper DMVs to see the total plan cache size now. There you go. So the execution is done, and you can see that there are 103 plans now in the plan cache, and the size of the plan cache is 1800 kilobytes. And I can tell you that those 100 plans are the 100 executions of that query, right? That is what it is. How do we prove that? Okay, so let's go back and run this statement, which I skipped on the top. Oh no, it's on the bottom. Where? Let me just go and see. Yes. So going a little internal into the query execution and the query structure. So there is something called as the query hash, which is the signature of the query. How this query is interpreted inside SQL Server is that select something, 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 where manager ID is equal to 1, where manager ID is equal to 2. So look at the structure of the query. The structure of the query remains same. It is only the manager ID value that is changing. So the hash, the signature is same. So can I ask SQL Server to group all the queries in the plan cache and group them by query hash, which is one of the attributes in my DMV dim exec query stats, and I see where having count is greater than 1. So I can actually group all the similar queries together where their hash, where their signature is same. And do I have any one of those? Yes, there is one. There is one query where the number of entries are 100. There are 100 instances of this query, and the sample query is right out there. This is select employee ID, national ID number, right? This is our query, and there are 100 instances of this query in the plan cache. So that proves the point. Now, what are you waiting for? What is the fix? Well, the fix is this. Let me take a moment to explain you the fix. The first part of the query here is kind of same, where you write the query, put the query in SQL string local variable. But see what you're doing. You're saying where manager ID is equal to @manager ID. Now this @manager ID is part of your SQL statement, and it goes into that local variable. But where is this manager ID, @manager ID coming from? This is called as explicit parameterization. So what I have done is, you have taken another local variable here. A local variable is defined here called param definition and varchar 500. And what we are trying to do is all my parameters are going to be explicitly defined, and I'm going to put them in this local variable. So if you see here in line number 91, I'm doing this. I'm saying set param definition equals to @manager ID tiny int. Because I know that there are not going to be more than 100 managers, I take the data type tiny int and I put them in @manager. I defined the parameter with @manager ID, and I just take tiny int because it's not going to be more than 100. Now, this parameter goes into my local variable param definition. So what if I had multiple parameters? Well, very simple. I would just separate them by comma, put more, separate them by comma, so on and so forth. So all parameters are explicitly defined, and this is what we called as explicit parameterization. So now remember that this @manager ID here should match this @manager ID here, of course, because you want this to be contextually same. Now let's look at the execution. Now, when you execute, you say execute sp_execute SQL. This is dynamic SQL execution. Where is the statement? The statement is in @SQL string. It is inside this local variable. Where are my parameters coming from? My parameters are coming from this local variable @param definition, where I've defined all of this, isn't it? Now comes the last part. You have defined your SQL statement. You have supplied the parameter definition to sp_execute SQL. But what about the values for those parameters? Well, you put a comma, and I'm just talking about the syntax here. You put the comma, and then you say @manager ID. Now remember, this @manager ID here, this @manager ID here, and this manager ID here is all same. And you say @manager ID is equal to CNT. So the value for @manager ID is again coming from that local variable. We're doing this counter improvement, which means if you actually had more parameters, same thing, friends, just put comma, something, 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 right? And you say is equal to, which is parameter equal to some other variable. And you can keep separating them with comma and get the total parameter set done. So this is really part of the syntax. It's a little, I would say, it's just, first time when you see all of this, it just is a little tricky. In case you have been doing this, this would be like, wow, why is Amit spending so much time on this? I'm spending so much time on this explaining the syntax because it was a little difficult to get this to the developers initially, people who have probably are looking at SQL server's parameterization thing for the first time. But then the folks who have been working with Java or .NET developers, they know that you can declare even explicit parameterization in the client code. You can do this with classes and objects there. So that's the part of the syntax. You declare the statement, you declare a local variable which has all the parameter definitions, and then you supply them in your dynamic SQL execution, and you tell them where the value is coming from. Quite simple. Now, let's free the proc cache again and go back to the helper window there and see how many plans you have. You have again 2 plans and 192 kilobytes is the plan cache size. Now let's go and execute this entire query. And hopefully now you will see that there will be no plan cache bloating. Probably there will just be one plan in the plan cache. And that is going to be a parameterized plan. This is what you expect. This is another common thing that we see now. You saw it took me so much time to explain this, but there are more aspects to it which I'm not covering in this demo. Okay, so let's go and execute this. This is done, and you can see that there are 4 plans. Something else is also there. That's fine, but just one plan for the execution that you did, and now the plan cache size is 264 kilobytes. Remember, earlier it was 104. And the total plan cache size was 1800 kilobytes. Look at the difference. Look at the amount of time we are saving. The CPU time also we are saving. Otherwise, computing so many plans. Now there's just one plan. We're saving a lot of optimizers' time. We're saving on memory. Remember, plan cache memory comes from the main memory, and it's one of the memory clerks, just like buffer pool. So you really don't want plan cache bloating. And in big environments, if there could be hundreds and thousands of such ad hoc plans. And if, of course, the plan cache hits the limit, plans will get kicked out of the memory. Then, and the same query comes again. The plans are going to be recomputed, recompiled, regenerated, and all of that, causing extra CPU cycles. All right, friends, let's close this one. So this was the 4th demo done. Let's move on to the 5th demo. How are we doing on time? Well, we're just touching about an hour, and we have 2 more demos to go. Okay, so let's go into bookmark lookups now. Bookmark lookups are good, but sometimes they can go very bad. I've seen the good side of things. I've seen the bad side of things. And when I'm showing this demo, I want to thank Adam Mechanic. I'm using his big database, because sometimes to show these big demos, you need large data. So I'm using his scripts to create the large data set, and this particular script as an example to demonstrate the bad behavior of bookmark lookup. But the learning is not only with bookmark lookups, there are some more learnings here. So let's dive deep straight away into this. We're using AdventureWorks 2016. Let's go and look into a query. There is this query where you are retrieving some data from transactions table in DBO. So this transaction table is a big table with 3.9 million records, about close to 4 million records. And there is another table called big product table, which is not very big, but it has just 25,000 records. So your query says that you want to fetch data into this temporary object #x, and you're fetching the data from big product table, and you do a cross apply with this inner expression, and the inner expression is fetching data from transactions table. There is some filter on the product ID. So a relatively simple query with an outer and an inner expression, and you're joining them using cross apply. Let's turn on actual execution plan and execute this query, and let's see how much time this takes. So this query is going to run. It's going to put data into this temporary object #x. So this select into statement takes how much time? It's going to execute this. Actual execution plan is turned on. In my last execution, it took about 6 to 7 seconds. Okay. Yes, it takes exactly 7 seconds. SQL Server is becoming more and more predictable with every new release. All these demos are running on SQL Server 2019. Now, if you go and look into the execution plan, this is a parallel plan. I can see a lot of parallel operators. Everything looks good here. 7 seconds, all fine, no problem. Now, let's go back to the query window and let's discuss a scenario. Now, let's say there was a need to add another column to the transactions table, right? The customer ID column. Now, this customer ID column to be added to the transaction table is not your requirement. I'm just making up a scenario. Maybe some other application, some other department, some other set of people just wanted to add customer ID, and the DBA goes and adds customer ID column to the transactions table. If you're thinking that in real world, it doesn't happen that way, there is a whole change management process that has to be put into place to add a additional attribute to a table. Let me tell you, in real world, it does happen that way. You just go and modify schemas. So all sorts of things happen. Anyway, that's a separate discussion and debate. But let's say customer ID column gets added to the transactions table. Now, did I really add that? Let's go and add this. Okay. Yes, it is added. And now what? You were not aware of this. Let's assume, because as I said, this was for some other application in some other department. But just like any other normal day, you go and execute your query. I need to drop the table to execute the query again. So let's drop the table. And like any other normal day, you go and execute your query now. And to your surprise, let's turn on actual execution plan and execute. Now this query takes a lot more than what it took earlier. And you know that that funny thing that we say, you know, the query is taking so much time that I can actually go to the cafeteria and have a cup of coffee, and while I come back, the query is still running and all of that. So while this query is still running, it has been over 7 seconds. Let's try to put that into action. Let me grab a bottle of water, and while this is running, let me drink some water. There's no coffee here right now in front of me, so water is good enough. Anyway, my throat was drying up a bit. Okay, friends, so this is still running. Isn't it that joke of the query is running and it takes that much time that I can go to the cafeteria and whatnot? Yeah, it is done. So it took about 51 seconds for the same execution. The interesting thing to note here is that, friends, only a column was added. You have not done any change to the data. So what has gone wrong? Let's go and look into the execution plan, and let's see the execution plan now. And all of you are seeing the execution plan. Let me ask you, friends, where do you see a problem in the plan? Now, don't say lookup just because I said lookup. You look at the plan and evaluate yourself. I know you may want to take the cursor over iterators and you may want to investigate. We will do that. But just on the first look, on the plan, where do you see is a problem? You can use the chat window to put down some answers. You can see a lot of iterators flying around there. Where do you see a problem? Any guesses? You can use the chat window, not the Q&A panel to answer. Q&A is for questions. You can use the chat window, okay? Someone says cost 80%, okay, for the key lookup. Sort operation could be a problem. Yes, there is a warning symbol on the sort operator. Good observation there, okay? Problem is lookup, key lookup, IO cost. Okay, lot of okay, nested loops and key lookups. Key lookups and sort both could be a problem. Yes, you're right, that both could be a problem. Okay, parallelism, fine. A lot of different answers, but yes, most of you are kind of right. When you look at the plan, your attention would probably go to the sort operator because there is a warning symbol there, and of course, in real world, we will not ignore that. And the other thing is the key lookup, because key lookup iterator cost takes up 80% of this relatively overall plan. Now the point here is, just for the sake of brevity, for saving time, I am not going and jumping into the sort operator, friends. I'm going and looking into the key lookup. Sort, just to let you know, it might be spilling the data, etc., but that's not the real culprit. So just for the sake of time, let's go and look into the key lookup. And you know why key lookup gets more attention here for me, at least, because of the cost factor. The cost factor is 80%. The sort operator, even though there is a warning symbol, the cost factor is 7%. I'm not trying to say that I'm not going to look into it. I will in real world when we are troubleshooting performance, but just for this demo, I am going to look into the key lookup. So when I take the cursor over key lookup, you can see that, okay, what do you see? You can see that the object here is PK transactions that we are looking upon, and the key lookup is fetching a column customer ID. That's the crux here, friends, okay? Which means what? Customer ID was not there earlier in the first execution. We added customer ID to the transactions table, and I'm assuming, but I'm going to verify this. Probably there was an index which was covering the query and all the data was coming from the index. But now because you have this additional column customer ID, which is not part of the index, and because your query says select star from transactions table, which means get me all the columns from transactions table, the optimizer has to apply a key lookup to fetch this additional column. And why is it so expensive? It is expensive because, friends, you are executing this key lookup 3.9 million times, one for each row to fetch the data. So you get the data from the index, but there's no customer ID. You want customer ID. So go and look up on the base table, get the customer ID value. Then the second row, go look up, get the value. Then the third row, go look up, get the value. You do that 3.9 million times. That's why it took so much time that you had a sip of water in between. Okay. So this is what is happening. Now let's try to corroborate a bit. How are we going to decipher this? SQL Server gives you a missing index hint. So I'm going to right click and look into the missing index details. Now, when I look into the missing index details, again, there's a lot of advice on the internet that missing index hints are bad. You should just ignore them or not blindly create them and all of that advice. Some of that advice is right. Don't blindly go ahead and create the indexes recommended by SQL Server. This is a hint, right? A hint is a hint. Just take the hint, try to understand why is Management Studio, why SQL Server, it's not Management Studio, sorry, but why SQL Server recommending you this hint, and of course the missing index hints are playing in the background, but anyway, why are you really getting this recommendation? And then try to evaluate this recommendation based on the existing indexes that you have. So what is SQL Server telling me here is go ahead and create an index on product ID there and include transaction date, quantity, cost, and also include customer ID. This is interesting. So let me do something. Let's go to databases, expand Adventure Works 2016, expand tables, and expand DBO transactions, go on to indexes. And here is the index, non-cluster index. Right click and let's script this out. And let's look at the structure of this index, the definition of this index. What are the key columns and what are the columns that have been included? And when you look at this index, friends, you can see that this non-clustered index actually has product ID and transaction date as part of the key columns, and it includes quantity and actual cost. Now, I would really spend a lot of time on this, but just the key summary here. There's another column called transaction ID in the transaction date, but transaction ID is the clustered index. So transaction ID clustered index is already part of every non-clustered index because it is the clustered index. So you don't need to explicitly add that, which means this actually was the covering index until the customer ID column came. Till the time customer ID column was not there, this index had all the columns that the query wanted. So there was no need to do the lookup. Now, because customer ID is there, SQL Server recommends you to create another index where you can include customer ID so that this new index becomes the covering index and it satisfies the query and there will be no bookmark lookup. That is the crux. So what are the solutions in front of you? Well, the solution is you can just go ahead and create this index, solution number one. But that would be the worst thing you will do because you don't need another index. An existing index is already there. Best of all, probably you could just add customer ID column in this included section here. Job done. You could do that. But you know what? I'll go one step ahead. and tell you something which is very, very fundamental, very, very rudimentary. And developers, DBAs, all of us, I mean, even I make those mistakes. We don't follow the guidelines and the best practices. You know, the problem is not with adding customer ID as an additional column. The problem is not even with index. Even though by creating this new index or by modifying an existing index, you can solve the problem. But you know, the real problem is here. This is the real problem, friends. Select star from transactions table. That's the real problem. Why star? Why do you want all the columns? And even if you want all the columns originally, why don't you specify the column names? Remember the problem that I talked about. Customer ID as an additional column was not your requirement. If this query was actually written by, if this query was actually written with specifying all the column names that were required, those transaction date, ID, actual cost, and whatnot, it wouldn't mention customer ID. And then why customer ID? Any number of columns that were getting added to the transactions table, your query would run actually absolutely fine and would avoid the bookmark lookup. So what I'm trying to say is this, friends. Here, look at this. I'm specifying the columns that I want. So see where we all started. Bookmark lookups do get expensive. Those are areas where you should look into, but remedies could be many. There could be very different diagnoses that you can do. So in this particular example, at least the diagnosis is not to create the new index, not to modify an existing index. In some other scenarios, that could be a solution maybe, or that could be required. But in this particular case, the need is just to make sure that you write the query in the right way and you follow the best practice, which is specify the column names, avoid select star. And if you go and execute this, see, I'm not making any change, but let me first, friends, drop the table. And if I specify the columns that I just wanted, so this is the query. Let's go and execute this. How much time will this take? And we are including actual execution plan, which is fine. This should again take just about 7 to 8 seconds, what it originally took. So yes, there you go. And it takes about 7 seconds. So many learnings from this one single demo. And you know, friends, we talk about the putting down the column names and avoiding select star and all these best practices. You know this, I mean, because these are the first few things that we learn when we learn about SQL Server or we learn about databases. But there's another thing, testing your query with real data. With most of my customers, what I've seen is when we are writing such queries, you know, this actually showed up as a slow running query because it was looking up on a table with like millions of records. And when it was really fetching and executing, iterating so many times, millions of times, it was running so slow. When I write this query in my dev environment, I'm testing it against small tables with just like thousands of records. This is just going to run so fast and there wouldn't be a problem. But when I take this query in production environment, and put it up against large tables, that is where performance problems are going to come. So the learning is in your development environment, in your testing environment, make sure that you're testing your queries with some real data. It may not be exactly production data, but today there's so many free tools available to kind of create and, you know, blow up the table and put like millions and billions of records for you to test. Take my word on it. I have seen developers testing their queries against empty tables, no data, and query runs absolutely fine, right? Now stop laughing. You and I, we both have done that. Okay. Let's move on. So a lot of learnings from this one, and let's do a bit of cleanup and drop this column. And friends, there we come to the last demo of the day, which is query tuning parameter sniffing. And this is a bit relaxing because this is where I think parameter sniffing is recent times has been talked a lot about. So many of you might know about parameter sniffing, but let's see what is happening. So we discussed about parameters a bit when we were doing the other demo about dynamic SQL. This is a little different flavor of parameters. And let's first create a stored procedure, run it, and then understand the concept behind parameter sniffing and how we can actually fix it. So I'm using AdventureWorks 2016. Yeah, that's fair enough. Let's use that. And There is a stored procedure, get customer ship dates, which has two parameters there, ship date start and date end. And the stored procedure is quite simple. Simple select statement here, where I'm fetching data from sales order header table, where the ship date is between the start and the end. Quite simple. Let's go and execute this. And then if you scroll down, we'll create an index on ship date just to support the select query. So let's go and create an index here. You know, this is going to be a good demo because it's going to sum up many things about scanning, seeking, parameter sniffing, and lookups and whatnot. I don't know. It's a coincidence. I didn't plan it that way. But anyway, so the stored procedure is created. You have created a helper index just to speed up the select statement, which is inside the stored procedure. And now let's free the proc cache, clear off the cache again, because it is a demo, I'm doing it. And now let's run the stored procedure with a different set of parameter values. The first execution gets us all the data. Let's call it 2020, okay? And it's getting us all the data of last 15 years, this execution. And the second execution of the stored procedure is only going to fetch me 10 days of data from July 10th, 2005 to July 20th, 2005. So let's free the proc cache and let's execute the first execution. Let's do the first execution. When we do the first execution here and click on execute, you will, okay, then let me turn on actual execution plan. I didn't do that, so execute it again. And you are going to see that SQL executes it, good, you get 30,000 records. If you look at the status bar, no point zooming in, we fetch all the data, and you are seeing a scan plan there. So if you see, this is a clustered index scan that is happening, and rightly so. Optimizer sees that you're getting a lot of data. The query is low selective, which means getting high number of records, and it decides to use a scan. Now, let's free the proc cache again, and let's execute the stored procedure again now. And now, again, this is a fresh execution. And this time, the query is highly selective, only 10 days of data. And we execute this, and you get no data, which is fine. Getting no data is also highly selective, and you go and look into the execution plan, and this time you get a different plan. You don't get a scan plan, you get a seek with key lookup. Now don't confuse with key lookup here with other key lookup things that we have talked about in previous demo. Let's just stick our head to this demo. Two different executions of the stored procedure separately and two different plans. What's going on? Well, this is called as parameter sniffing. In each execution of the stored procedure, the optimizer sniffs the parameter value and generates an optimized plan based on the parameter value. Now, there is a thing about the stored procedure, which is good. Stored procedures encourage plan reuse. So in the stored procedures are compiled objects. In their first execution, the execution plan gets created and it gets injected into the plan cache. Subsequent executions of the stored procedures reuse the plan, which is already there in the plan cache. But in our example here, what has happened is when I executed both the stored procedures, I was clearing the cache in between, which means every execution was a fresh execution of the stored procedure, first time execution of the stored procedure, and there was no plan in the plan cache. So the optimizer creates a new plan every time. And then you see the parameter values are different, so it generates a new plan every time. But now look at the fun. This is not what is going to happen in real world, isn't it? No one is going to fire free proc cache or something before or after every execution of the stored procedure. In real world, this is what is going to happen. When you execute the stored procedure for the first time with the first set of parameter values, which is getting all of the data, you are going to get a scan, and the scan plan gets injected. Another user comes with a different set of parameter values, making the query highly selective, different values, and you execute this again. You are only getting few records or no records, highly selective, but the optimizer forces itself to use the scan plan, which is already there in the plan cache. And look at what happens here. The second execution, subsequent execution of the stored procedure lands up using the scan plan. Fine. But then something else could have happened, which is instead of the first set of parameters coming in first, you could have this execution coming in first. There's no plan in the plan cache now. The first execution of the stored procedure itself comes with highly selective parameter values. Execute this. And what happens? The seek plan gets injected into the plan cache. Quite interesting. And the subsequent execution could be this probably, where it wants a lot of data now and making the query low selective, and you execute, and this forces the optimizer to use the seek plan with key lookup, fetching the data from the table, forcing itself to use the seek plan. And the same problem, you have the key lookup where the key lookup execution is 31,000 times. Now the table is small with 31,000 records. Imagine if this was 31 million, this could have taken minutes to execute. This is the problem called as parameter sniffing. Parameter sniffing is a good thing in general because the optimizer sniffs the parameter values. It's great. But sometimes it can cause this kind of problem where a plan gets injected into the plan cache based on certain set of parameter values, and all parameter values that are good for that plan, it's great. But then if your database table data is column values are skewed up, right? Skewed distribution of data where you have different parameter values and all varieties of parameters coming in. And there could be some other plan that could be good for that, the optimizer. And because of the way stored procedure reusing plan, it encourages plan reuse. It will force itself to use those existing plans in the plan cache. And friends, this is the reason why sometimes in your SQL Server environment, when you have these stored procedures, sometimes they run fast. Sometimes they run slow. Sometimes they're running fast again. Sometimes they're running slow again. And all this is happening in background. Parameter sniffing is probably happening in your environment. Now, how do you fix it? Again, it's a big concept. There are a lot of other things that I can talk about, but a quick fix could be to use the statement level recompile hint. So I'm going to drop the stored procedure now, and I'm going to modify the stored procedure in this way. I'm going to create the stored proc again with the parameter, the variables, parameters, and I'm going to say for this statement option recompile. I'm sure you have probably come across this hint option recompile where I'm telling the optimizer that, you know what, when this stored procedure comes for this particular statement, don't store the plan. Every time compile it again based on the parameter values. So this is going to do the trick. First, now the moment I say this as a solution, as I said, this may not be the best solution. It's a quick solution, elevates a lot of other problems. But now the moment you hear me saying that every time the stored procedure comes again, create the plan again, you're thinking about plan cache recompilation, extra CPU cycles being consumed, more time and all of that. I'm going to come to that. But let's first see if the problem gets solved. So you have created this stored procedure, you modified it. Let's go and execute the queries again. First execution of the stored procedure. What do you get? Get me all of the data. You go to the execution plan. It's a scan plan. All right. Second execution of the stored procedure. Let's go and execute this and go to the execution plan. You get a seek. I'm not running DBCC free proc cache in between, isn't it? Let's go and execute the first one back again. And you will see a scan plan again. So every execution of the stored procedure, you get a fresh new plan based on the parameter values. The previous plan is not stored in the plan cache. Now you're thinking about the cost factor, because every time the plan has to be, compiled, optimized, and, extra CPU cycles, etc. Well, there is no magic bullet here. It's about trade-off. Very simple. To gain something, you have to lose something. This is an old saying which you have heard all the time. So the whole idea is if the trade-off is good, today modern hardware is quite powerful, right? Storage, CPU, huge memory on boxes. So there are CPU cycles available. With those additional CPU cycles, if the trade-off is that you're saving so much on query execution, if they're running fast, why not? If trade-off is good, go ahead and use it. So that's the whole idea of parameter sniffing. Many of these topics are quite require more debates, longer discussions, more scenarios, but that's what a free session is all about. Well, on SQLmaestros.com, friends, beyond the virtual summit and all of that, I do have a lengthy video course also, which is just like as interactive as this. I'm on screen, but much better with green screen setup and all of that. So go to SQLmaestros.com, check out the performance tuning video course, which is a 15-hour course packed with a lot of demos, a lot of modules. Maybe you may like that and you may want to subscribe to that. Go ahead and do that if you think that's worth it. But for this session, these are the 6 demos. And as I said, the 6th one was quite interesting. It summed up so many things about scanning, seeking, bookmark lookup. The same concepts came again. But then, yes, friends, that's the summary. These are the 6 things that I see commonly. But I'll tell you, these are just not the 6 things, but I just picked up some random 6 common query tuning techniques which can solve 75%. Maybe it will solve 60, 65, or maybe even 90%. That's relative. But yes, common problems that you see in SQL Server. And I hope your time was useful in today's session. You learned something new. Do give feedback, friends. The link is there in the chat window. My colleague Satya is just posting it. So I would want to hear from you. If this session was worth your time, please give some feedback. The LinkedIn link is there in the chat window. If you click on that, I hope Satya it has gone to all the attendees when you're posting it. Great. So I'm waiting for feedback and post something there. Visit dataplatformvirtualsummit.com also and explore the content, friends. Content is king. Content has to be meaningful for you. Just don't buy a ticket and come up on board on any conference. Look at the content and compare it with the price. I truly believe that the team has done an incredible job here trying to put up all of this together at a very, very affordable price. Even if your company and your managers are not sponsoring you, you can still think about coming on board. So 2 things. Yes, please give feedback. Follow me on Twitter, _Bansal. Please feel free to give some feedback on Twitter as well if you are a Twitter user, and on LinkedIn. And yeah, I had a great 90 minutes of this session. Time to jump into question and answers, right? So your questions, if you're on YouTube, post it on YouTube chat window, no problem. And if you're on Zoom, let's use the Q&A window and let's start getting down to the questions. So the first question, Tejas has a question. How can we use index seek using convert functions? Do we need to create compute columns which convert date time into date and use directly in variable in where condition? Yes, Tejas, you can actually use cast and convert to do explicit conversion, and that might work better. But there is a catch to that also. There's an exception. If you go to sqlmaestros.com, look at some recent blogs. I did post a very long blog where cast and convert was also an exception to sargability. So while in most functions it will work, but there could be some exceptions as well. Next question is, Gabriel, the key lookup I still see is inefficient. Okay. Well, Gabriel, see, it's not about any iterator being efficient or inefficient. These are different access methods. By that logic, I can always say scan is always inefficient, but nothing is always bad or nothing is always good, so to say. And the best answer, which you don't like to hear, it depends. So given a problem, let's take the problem at hand and then try to figure out what's good or bad. Relatively small set of data lookups could be good, but you just can't keep creating covering indexes to avoid lookup. That could be bad in the other world. I know that was not the answer you were expecting, but that's all I had. Akshay has a question. I have a doubt in the where clause, you haven't used business entity ID in the where clause. So how index scan is being used? Okay, Akshay. That's one of the challenges of taking all the questions at the end, because your question is about a specific demo. So Akshay, which demo is this about? Maybe Satya is following. He may tell me. Business entity ID, was this okay? Doubt where clause, haven't used business entity ID in the where clause, index scan is showing. So this was one of the early questions probably. So am I using why seek is not happening? So that question came at 7:26, maybe in the second demo of there. I think your question about business entity ID could be because it's the clustered index. So if I'm using that, maybe it would be only seeking. But can you just rephrase which demo you're talking about? Post that again. I will answer that question with the demo. Promise. Jayhawk has a question. Do you have any recommendation for understanding how to analyze the execution plans? Well, Jayhawk, simple guidelines are there. Look at iterators with warning. Look at iterators with cost factors, high cost factors. Look at where is huge amount of data flowing in. The visual indicator of the arrows are good. That helps. Always take a point to go and look into the select operator, because when you take the cursor over select operator, it gives you if the query has been using extra memory grant. Those are some general guidelines. I also go one step ahead and try to figure out cardinality estimations. So if you take the cursor over arrows, apart from the number of rows that are being transferred between iterators, try to look at cardinality estimation factors. Those are important because they may tell you are statistics being up to date and whatnot, right? So just general guidelines, again, much larger topic. Anmol has a question: how covering index work in case of execution plan? Well, Anmol, it's not about how covering index will work in case of execution plan. I mean, if you have a covering index, SQL will either just scan or seek. The whole idea is a covering index is an index which contains all the data that your query is asking for. So if your query has select column A, B, and C, and let's say there is an index which has A, B, and C, in whichever order, it could either scan or seek. And when it would scan, when it would seek, that I've already explained in the first two demos. Akshay has a question. Let's say we create an index on A, B, and C. There is the order of index creation. Okay, A, B, and C. Now in the where clause, I say B is equal to X and C is equal to Y. So will it use seek? No, it will not use seek because you are not seeking on A. So it won't seek on B and C. It will be a scan. What if C is equal to Y did not use the seek? What if A is equal to, then it will use seek? Yeah. So in the order of columns, as I said, because A is the first column in the index, you have to seek on A if you want to seek on B and C, right? And in that order. And you can try that out yourself. I mean, just write a simple query with an index with 3 columns and play around. Santosh, hi Amit, session is going really good. I have a question. How does optimizer handle conversion on var binary or text data type columns? Example, select start from table where call one like something percentage. Var binary and text data type, which are LOBs, large objects, conversion on them. Sorry, Santosh. I don't have a good answer for that right now. Maybe just got to look into it. So, Satya, take a note of this. Try to post this question in our LinkedIn group. So, friends, have you joined our LinkedIn groups? Do that. We can continue doing more discussions even beyond the session. I'm hitting 8:30 now, and that is where I will have to wind up because I have another session coming up for a customer. But I'll just quickly go over this. So, Santosh, post that question there. I'll do some research and get back to you on the LinkedIn group. So you can join either SQL Maestros or SQL Server Geeks group, whichever you like, no problem. Okay. Shilpa has a question. Is there any way to avoid cross-apply table? If there's any way to avoid cross-apply table with a table valued function so it's causing performance issues? Shilpa, completely different topic altogether with table valued functions and cross-apply some other time, right? Or just post the question in the group, because TVFs is a different discussion altogether. And I know where is this question coming from. TVF creating performance issues because it's constantly running for every row from the outer expression. So I know where it's coming from, and it won't use stats and whatnot. So cardinality estimation will go bad. Rahul, can scan be useful over seek in some cases? Yes, Rahul, scan can be useful over seek in not some, but many cases. 310541 has a question. That's a great name, 310541. So 310541 asks a question: is it good choice to use recompile everywhere? No, it's not a good choice to use recompile everywhere. I just showed you a demo and a scenario where it could be used, and it is a hint. Hints are really the last thing we should try to use when we're doing query tuning stuff. So as I said, nothing is good or bad, all the time. It really depends on the situation and scenario. And then Ganesh has a question, how to find parameter sniffing is happening. Great question, Ganesh. Thank you. How to find? Well, if you are on latest versions of SQL like 2019, 17, 16, you can use Query Store. They help you identify. But if you're not using Query Store, or if you're on 2012 or 14, something like that, then there is a way on how you can fetch the information from a Query Stats DMV, where Query Stats DMV has the information about the time it has taken for the current execution and the time it took in previous execution. You have to find out a relative factor, that is, there is a big difference between the two times, and extract all those queries. And probably, potentially, there could be a parameter sniffing problem there. Not always, but potentially. That's the answer to that. So I think in SQL Maestro's YouTube channel. So friends, I will invite all of you to subscribe to the YouTube channel. Please, Satya, if you can put the link there. There are a lot of videos out there, and you can just spend days and days learning a lot of free stuff out there on youtube.com/SQL Maestros. Do subscribe to that channel. There are a lot of videos out there. And Ganesh, there is a video under the playlist called SQL Shigra, where I've talked about that. I didn't post the query there, but I've explained you how it can be done. And thanks, I will, in some days to come, I will write a query and I will put it up in LinkedIn group, or I will blog about it. So Ganesh, you will get the answer to that. So that's the channel there, youtube.com/SQL Maestros. Please go ahead and subscribe to that. Thank you, friends. Tejas has another question. How can we use index seek using convert function? Do we need to create? Okay, this I answered. This came a second time. Okay, Setu has a question. Does index seek include columns play a vital role in performance tuning? Yes, they play a vital role. They are very powerful. Remember in SQL Server 7 and 2000, this include thing was not there. And we used to dump all the columns in the key definition. That used to increase the size of the index key, which increased the, the length of the key on the page. And it increased more intermediate levels. That was very bad. So include is good. But remember that if you put a particular column in include keyword, you cannot seek on that. You can only seek on the columns that you put in index key definition, right? Otherwise, including columns in the index using the include keyword is actually quite powerful. Okay. Farang has a question. Any device for keeping system? Friends, I hope those who are leaving, are you giving feedback on LinkedIn? Please do that. That's the only thing I ask, right? And the other thing I ask is you should join dataplatformvirtualsummit.com. Okay. Farang has a question. Any device for keeping system generated statistics up to date? Farang, big topic about statistics, slightly out of context for today's session. So I invite you to join the LinkedIn group, post the question there, and we can have some discussion. Friends, we have Telegram groups also. In case you are a mobile freak and you like asking questions on mobile, my friend Satya can put Telegram link also. So we have Telegrams for SQL Maestro, SQL Server geeks, and data platform geeks, and even DPS for that matter. So you can join. Telegram app is just like WhatsApp, app. So you can join. But the good thing about Telegram is your mobile number is not exposed. And that's why we prefer Telegram. The other thing is groups can have more members, more beyond the limitation that WhatsApp has. And there are a lot of Q&A happening there. In recent times, I'm not very participative because of the DPS work. But the good thing is community helps. So as a community member, you can ask questions. You can also answer questions of other folks. Okay, friends. So Mrunal has a question regarding dynamic SQL plan cache. Can we use the same cursor rather in while? No. Avoid cursors. Try to stick to relational set. Sometimes cursors are the only solutions. You can't help much with that, but try to avoid cursors in general. Santosh has a question. Procedure means one-time compilation reuse many times. Procedure means one-time compile and reuse many times. Yeah, Santosh, I think that's what you meant, right? You create the compile and the plan gets reused, correct? Akshay, when you create an index on a table with column of SPUs, okay, more and more questions are coming. Can we get the recorded? We'll work on the recordings, Anurag. Let's get all these questions answered now, okay, in parameter sniffing. Okay, Akshay, when you create an index on a table with column, if SPs using that column, then SPs will get recompiled. If not, when recompiled, so then we plan. Akshay, I'm not able to follow your question right now. If you could just rephrase it. But then, friends, we are on the top of the hour and I have to end the session now. beyond 8:30, need to jump into another meeting, but it has been, so Akshay, please post your question in the LinkedIn group. I'll come back to this again. More questions, I'll come back to that. Please give feedback on LinkedIn, join our groups, YouTubes and Telegram, and let's stay connected and talk to each other more about SQL Server and performance tuning. With this, I'll wind up today's session. Thank you very much, all of you joining. Hope it was worth your time. I really enjoyed delivering this session for all of you. And wherever you are and whatever time is left of the day, have a great day. Have a great sleep if you're in around APAC time zone, etc. Thank you very much and see you soon. Maybe see you at DPS 2020. Goodbye. The whole world is joining Data Platform Virtual Summit 2020, and there are some very good reasons for that. The summit runs 72 hours non-stop continuously round the clock. Not only the summit, even our pre-cons and post-cons run round the clock, which means the entire package covers all the time zones, all the countries. Whichever part of the world you are in, you can join the summit. All in all, we have more than 200 sessions to choose from, and you have about 30 training classes to join. This is true value because not only do you attend live, but you also get the recordings for it. And thanks to our speakers, all this is brought to you by more than 170 speakers. About 100 are from the community and more than 70 speakers from Microsoft. Let's mention and special thanks to our training class speakers. They have agreed that their classes could be recorded and the recordings can be shared with the delegates. So hats off to them. These are world's best educators. We have covered you. Our technology tracks cover on-prem, cloud, database administration, development, advanced analytics, artificial intelligence, and this time there is a special track, industry solution, where speakers are going to share real-world experiences with you. Yes, so we have freshly baked sessions for you, and you will see that content is king for us. Highly curated session, highly selected session. And all this comes to you at an incredibly affordable price. In less than $300, you can buy the summit ticket and you can choose a training class for yourself. The price is so low that even if your company is not sponsoring you, you can buy the ticket on your own. So why wait? Log on to dataplatformvirtualsummit2020.com. No, dataplatformvirtualsummit.com and evaluate the summit for yourself and see whether it is worth your time and money. And I'm sure you are going to be a winner. Get the DPS ticket today. Grab the content. If you join DPS 2020 training class, you get to attend live and you also get the class recordings to watch over next 12 months as many times as you want. Let's get started. T-SQL Guru Itzik Bengan joins us. DevOps Master Alex Yates. ETL Gem Andy Leonard. The world-renowned Bob Ward and Anna Hoffman with their popular class Azure SQL Workshop. Kubernetes, look no beyond Anthony Nocentino. Anupama Natarajan from Australia on machine learning for developers. No one knows SQL Server big data clusters better than Ben Weisman. Another ETL gem, Benjamin Kettner. Want to dive deep into data science algorithms? Join this class by Dejan Sarka. Get real-world experience into enterprise Power BI with the help of Dr. Greg Lowe. Another SQL community gem and Microsoft Certified Master Edwin M. Sarmiento with his class on SQL Server and Docker containers. The best SQL Server performance tuning class comes to DPS by Eric Darling. Niche topic Cosmos DB by Hassan Savran. Yay! Itzik Bengan does his second training class at DPS. Kelly K. Power BI admin. Then Kevin Faisal comes with data analysis in Python and SQL. Niche topic. Want to do self-service AI on Power BI desktop? Join this class by Marcus. Niche topic again, Azure SQL DB performance tuning by Martin Kerde. Want to do some deep dive into SQL Server migration? Join this class from Microsoft with the help of Mukesh and Raj. World-renowned expert on Power BI, Peter Mize comes to DPS for the 5th time with his popular class Power BI desktop modeling. Philip Seamark does DAX in a day. Prashant Boyer with Microsoft Conversational AI Masterclass. Community gem Rob Sewell with his PowerShell and SQL Server DBA tools. Siva Harinath with Dashboard in a Day, Jana Berkovich with Power BI Data Visualization, another SQL Server expert Uwe Ricken with his performance tuning class. Want to deploy SQL Server on Azure VMs? Join this class by 5 experts from the SQL Server team. And yes, Synapse is the buzzword in modern analytics. Join this class by Warner Chefs. So much to choose from. Be a winner. Join DPS today.